Hello again and welcome to the lesson video notes, and this time is for lesson 7.4, parallel lines and proportional parts. Alright, in the past we've used proportions to solve problems between similar triangles. Well, we're going to use some of that same idea into being able to use proportional parts within the triangles and proportional parts within parallel lines intersected by transversals. So let's get started right away. Here's our first theorem. It's called the triangle proportionality theorem. Alright, if a line that is parallel to one side of the triangle and it intersects the other two sides, then it divides these other two sides proportionally, or divides them into proportional lengths. Now, this comes from the fact that we get similar triangles, ABE and ACD, and the proportionality of their sides would tell you that this segment, BC, added to AB gives you that full side length. Well, since the ratio of AB to the full side length is the same as AE to its full side length, then the ratios of these two parts would have to also be the same as these two sides of triangle ABE. And that's where we get this information. So these segments are proportional to these segments. So in our first example, we have triangle RST. We have RT parallel to VU. And then SV is 3 and RV is 8. UT is 12. We should be able to find SU. So we're going to call that X. Well, since these are parallel lines, we know that they separate these sides of the triangle proportionally. So we can set up our ratio real easily. We can compare 8 to 12, and that should equal 3 over X. Now, that's not the only way to set up the proportion. You could also say 8 to 3 equal to 12 to x. Either way, you'll notice we're multiplying 8 and x and 12 and 3 when we take cross products. 8 times x here, 8 times x here. 12 times 3 here, 12 times 3 here. So either way, the cross products are both going to get you to 8x equals the product of 3 and 12, which is 36. And then we divide both sides by 8. Giving you that x is equal to 4.5. And x is the representation of side length US, or SU. SU equals 4.5 units. All right. So we can set up the same kind of proportion here. It's the very same situation. We have parallel lines XY and AC. So XY cuts AB and CB proportionally. So we should be able to set up a proportion. I want you guys to pause the video if you need more time, but go ahead and set up the proportion when you're ready to continue solving the problem. After you have the proportion written down, you can click play and you'll see what you should get. Alright, this is the proportion we should get. 4 over 6, or 6 over 4, since I wrote it backwards, let's start with that. 6 over 4 is the same as x over 10.5. That's not the only proportion that you could write, but when you do write your proportion, you should still get the same cross product that 4x equals 6 times 10.5 or 63. So we get 4x equals 63, and we divide both sides by 4, and we get that x is 15.75. And x is the length of BY, so that's our answer. Alright, remember that if we have parallel, a segment that intersects two sides of a triangle parallel to the third side, then it divides those two sides proportionally. Alright, and the converse of that is also true. If we have parts of a side of one side of a triangle that are proportional to two parts of the other side of the triangle, then these lines have to be parallel. So if we know that we have proportionality here, then we can say those are parallel. So here's what we have in example 2. We're verifying that these segments are in fact parallel. So here's what we need to say. We know that AC is 36. Okay, however you want to express that, you can do that. And BC is 27 centimeters. So we can find these other two segments by just doing subtraction. 36 minus 20 is 16, and 27 minus 15 is 12. So if these are proportional to these, then these have to be parallel by the converse of the triangle proportionality theorem. So let's try that. Let's try our ratio for DC to DA. DC over DA is 20 over 16. Should be the same ratio of EC to EB, 15 over 12. Now, we can reduce both of these, and they should reduce to the same fraction. 20 over 16, we can divide both of those by 4, and we get 5 over 4. 15 over 12, divide both by 3, we once again get 5 over 4. So these are proportional. Now that may not be the same way that you originally set that up, so let's look at our other ratio. Let's compare opposite sides here. 16 over 12 should equal 20 over 15. Okay, we can simply take our cross products to check and see if those are true. Let's try 16 times 12. I'm sorry, 16 times 15. 16 times 15 is 240. Let's see if 12 times 20 is also 240. And it is. Since cross products are equal, these are proportional. Since DE cuts AC and BC into proportional segments, DE is parallel to AB by the triangle proportionality converse. Okay? So to verify, again, you just want to check proportionality of these segments that you're given. So once again, we're going to compare these opposite segments, DB for this triangle to EC, and see if that equals the same as DA over EA. Okay, DB over EC is 15 over 12, and DA over EA is 10 over 8. If you reduce both of these, they should reduce to the same fraction. 15 over 12 reduces to 5 over 4. 10 over 8 also reduces to 5 over 4. So we have the same ratios again. If you wanted to try that out, use your cross products. But since they do give the same ratio, these are proportional, we can say DE is parallel to BC by the triangle. We can replace the word triangle with our symbol. Proportionality converse. Okay, and then that leads us to the very similar concept of the triangle midsegment theorem. Now, by definition, the midsegment of a triangle, this is a vocab term you do need to make sure you copy down in your vocab notebook. Midsegment of a triangle is a segment that connects the midpoints of two sides of a triangle, just like we had midsegment of a trapezoid. Okay, by definition, then, it is parallel to the other side, and it is half the length of the other side, just like our midsegment of a trapezoid. Now, allow me to kind of help you out and understand this a little bit better. The midsegment of a trapezoid was the average length of the two bases of a trapezoid. So kind of think outside the box with me a little bit. If I were to call this triangle a trapezoid where one side was a 0 length, let's think about that. It's kind of like a trapezoid, only one of the bases has a 0 length. It's 0 units long. Then this would just be the average of whatever this length is plus 0. Well, whatever this length is plus 0 just gives you that length. Half of that means we can just take half of that other side length. Okay? So the midsegment of a triangle is half the length of the side that it is parallel to. Alright, so in this figure we have a triangle ABC, and DE and EF are both midsegments of their respective sides. So that means AF and BF are congruent, and AE and CE are congruent, but also BD and DC are congruent. Now, if EF is a midsegment, which we've shown it is, then it is equal to half the length of BC. Well, that means we know D is the midpoint of BC, though. D is halfway between B and C, so D makes this segment 9 and this segment 9, so its mid-segment, EF, is also 9. And I'm just filling out everything I can about this diagram before I even try and answer these questions. Okay? Now, DE is another mid-segment corresponding to side AB. It's half the length of AB. Well, if F is the midpoint of AB, in order for that to be a mid-segment, then each of these is the same as that mid-segment, 5. And that means AB is a total of 10. All right, so let's look at what we're supposed to find. We're supposed to find that AB, we already did that, that's 10. We aren't given a unit of measure, so we can just write 10. FE is the mid-segment corresponding to side BC, so it's 9, we already found that. And then now we should find the measure of angle AFE. AFE. Do not assume this is a right angle. It does not actually appear to be if you look carefully, so we can't make that assumption. But we are given only one angle measure here. Well, remember, mid-segments are parallel to their respective sides. So ED is parallel to AB. That means that this angle created by FED, if I knew that part of it, I could find the supplement over here. So we've got a little bit more work to do before we can find the measure of angle AFE. Okay, but there's another way of thinking about this. If I think of this as my transversal, I'm intersecting parallel lines here. This 87 degrees would be congruent to this angle because they're alternate interior angles. So AFE, we already do have that measure, 87 degrees. Okay, and that leads us to a corollary of that, and that is our proportional parts of parallel lines. Let's assume that I had a triangle that the third angle of the triangle was out here somewhere where these lines intersect, but I had more than one parallel line intersecting these sides. I get just two different transversals among three parallel lines. That proportionality still exists. AB to EF would have to be the same as BC to FG, or AB to BC is going to be the same as EF to FG. We can also write the proportion that way. So we can use that to find measurements here. So we have a figure here where Davis, Broad, and Main Street are all parallel, and this figure shows these other two streets that intersect those three. We are to find the value of x, the distance between Broad and Main Street along Bridgeview. So in order to do that, we're just going to set up our proportion. Because these lines are all parallel, the ratio of 15 to 24 has to be the same as x to 8. Okay, I'll let you cross multiply and solve for x and check your answer. Okay, this is what we should get. When you cross multiply, 24x equals 120, and when we solve, x equals 5. Okay, now from that we get this other corollary about congruent parts of parallel lines. If we know that AB is congruent to BC, then that ratio becomes 1 to 1, so this ratio must also be 1 to 1, so these would actually have to be congruent. And we can actually eliminate having to solve a proportion when we do this by just, if these are congruent, then these are congruent. So we're going to use that fact to find x and y. Alright, since these are given to me as congruent, I know that their corresponding parts along the other transversal are congruent. So 3x minus 7 should equal x plus 5. And we can just solve that equation for x. Similarly, we have our equation 9y minus 2 equals 6y plus 4. And you can only do this when you're given that one pair of those segments are congruent. And then you can make the assumption that the other two, if these are all parallel. So I'm going to let you solve those equations, pause the video so you have enough time to check those, and then check your answers by clicking play. Alright, when you solve for x, you should get x equals 6. When you solve for y, y should equal 2. If you're not sure, plug them back in and see if they get you the same value.